Wood is everywhere, from our floors and furniture to the smallest decorative details. But rarely do we stop and ask ourselves, where does it all begin? Today, join RaWMachines as we explore that journey, from silent, serene forests to massive, state-of-the-art factories, where raw logs are processed with cutting-edge technology and precision engineering. Let's get started. "6:40 a.m. As the first rays of sunlight filter through the canopy, the harvesters are already at work starting a new day. From a distance, it looks like a massive excavator, but at the end of its hydraulic arm isn't a bucket. It's a specialized harvesting head. The operator positioned the head around the base of the tree. Just seconds later, the saw blade cuts through the trunk, bringing the tree down. But that's only the first step. Heavy-duty rollers pull the trunk through the processing head, while delimbing knives press tightly against it to strip away branches. At the same time, the system continuously measures the length. Once it reaches the preset dimension, the saw instantly bucks the log to length. In a virtually seamless process, a standing tree is transformed into timber, cut to exact specifications for transport and processing, right on the spot. But there's a catch. These logs are still buried deep in the forest, and the road ahead is anything but easy. That is where the John Deere forwarder comes in. Unlike the harvester, its job isn't to fell trees. It's here to haul the logs out. The hydraulic boom at the rear continuously scoops up logs and loads them onto the bunk. The payload grows heavier until the forwarder is fully loaded and ready to leave the logging site. And this is where it gets tough. In many stretches, there is virtually no road at all. The tires have to find traction on soft, muddy ground, all while the massive rig maintains stability under a heavy load of timber. But the forwarder doesn't back down. It keeps pushing forward until every last log is safely delivered to the landing area. Here, another machine takes over, the log loader. Its long boom reaches out to the timber piles. The giant grapple closes in, and with a single lift, multiple logs are hoisted off the ground and placed onto the barge moored alongside. Pass after pass, the hold gradually fills up until the barge is fully loaded and ready for the next leg of the journey. The engines fire up. The logging site slowly shrinks in the distance, and the timber that once sat deep in the forest now moves along a completely different transit route, the water. For the next several hours, the barge carries them toward the mill, but when the shipment arrives, a rather surprising scene unfolds. Instead of using cranes to lift each log onto land, they do almost the exact opposite, dumping all the timber into the water. At first glance, it looks like complete chaos, but in reality, everything is part of a calculated system. Because at this point, there's no need to move each log by truck or crane. The water itself becomes the holding area and transport conveyor. And amid that sea of logs appear small yet extraordinarily nimble vessels, boom boats. Compared to the giant machinery that processed and hauled the timber earlier, they are much smaller. But here, raw power isn't the only thing that matters. Maneuverability is the real key. The boom boats weave through the gaps between logs, constantly pushing, pivoting, and guiding clusters of timber. Bit by bit, what looks like a chaotic mass of wood is organized into a controlled stream of raw material. From here, the logs embark on another journey where they will be processed into high-quality products at IFG Grangeville. Massive logs are loaded one after another into the automated feeding system. The first stop is the debarker. This seemingly simple step is actually critical. The bark must be stripped away to ensure precise sawing and to prevent sand, rocks, and debris stuck to the outside from damaging the high-speed saw blades. The debarked logs are then fed into the main saw house. Here, the log is clamped securely by a steel pulley system and flies down the conveyor at extreme speeds. In just a few seconds, heavy-duty saw blades slab off the outer edges, turning the round log into a square timber block. The cut-off waste immediately drops onto a lower conveyor. Instead of going to waste, it is routed to the chipper to produce wood chips. The square timber slides out and is instantly redirected onto a cross-transfer conveyor. From here, it passes through the gang saw, where multiple parallel blades rip the large timber into a series of thinner boards. Thousands of sawn boards stretch across a massive conveyor system, weaving through the mill like a spider web. This is the trimmer and sorting complex. First, unscramblers flip and align the boards, ensuring they move in a single file line. Next, a multi-saw trimmer automatically drops down to cut off defective ends and bring the boards to standard commercial lengths. The approved boards head to the automatic stacker. Layer by layer, the lumber is precisely collected and stacked into square units. Thin wooden spacers, stickers, are placed between each layer to create gaps for airflow. Once a unit reaches its set size, a heavy-duty forklift steps in, lifts the entire pack off the line, and moves it to the staging area, ready for a crucial quality stage. From above, the entire power and drying facility of Idaho Forest Group comes into view. Smoke and steam continuously rise from the massive boiler complex. Remarkably, part of the heat energy is generated right here by utilizing manufacturing byproducts like sawdust, bark, and wood chips. Forklifts load the large lumber packages into industrial dry kilns. Once the doors seal shut, the wood undergoes continuous drying for several days. Throughout the process, temperature and airflow are strictly computer-controlled to gradually draw moisture out of every board. This brings the lumber to its target moisture content while reducing the risk of mold, insect infestation, and warping during final use. After kiln drying, the lumber moves to the planer mill. An unstacker breaks down the packs, feeding the boards into a high-speed planer where all four sides are surfaced to a smooth finish and precise dimensions. Right downstream is a laser scanner, visible by its red light grids. In a fraction of a second, it builds a 3D profile of each board, detecting knots, cracks, and the smallest defects to determine the product grade. Based on the laser scanner data, the central computer directs the bin sorter. Hundreds of boards speed along on a lug chain conveyor. When a board reaches the specific bin assigned to its size and grade, the system drops it in. Once a bin fills up, the lumber drops down to be strapped into units. At the final leg in the mill, the lumber packs are compressed tightly into secure, square units. To protect the product during long-haul transit and against harsh weather, each unit is wrapped in branded weatherproof tarp and strapped down with heavy steel banding. From rough, rugged logs deep in the forest, the timber has now been transformed into finished building products, carrying the quality commitment of Idaho Forest Group. At the shipping yard, forklifts load the lumber packs onto flatbed trucks. Fleets of trucks leave the facility, hauling high-quality building materials to construction sites and wrapping up a complete manufacturing process. Not every log is destined to become ordinary construction material. Some conceal breathtaking grain patterns within, and the mission of Veneer is to discover, unlock, and preserve that beauty for the world's most luxurious architectural spaces. The journey begins in the heart of hardwood forests, where only trees with the highest aesthetic potential are selected. Upon arriving at the yard, each log is tagged, cleared of damaged sections, and prepared for a process of refined transformation. To capture flawless grain figures, the wood is not sawed into lumber. Instead, the logs are debarked and quartered or halved into large flitches. The flitches are then submerged in massive vats of boiling water. This cooking process is crucial for softening the natural fiber structure, turning rigid timber pliable before it meets the steel blades. Once the flitches are ready, they are fed into vertical slicers, where mechanical power meets exquisite precision. Multi-hundred-pound blocks of wood glide across a razor-sharp stationary blade, sliced into sheets just fractions of a millimeter thick without tearing the grain. After passing through the dryer, workers meticulously stack each veneer sheet in its exact natural order. This technique is like keeping the pages of a book intact, preserving the seamless continuity and symmetry of the natural grain. Alongside vertical slicing, the facility operates a rotary peeling shop dedicated to rare burls and rootstock. The gnarled burls are blasted with high-pressure water cannons to wash away dirt and rocks before being clamped onto a rotary lathe. As the burl spins at high speed, a fixed blade peels away continuous ribbons of veneer, revealing stunningly unique swirls and bird's-eye patterns. The veneer sheets then move to the inspection area. Technicians flip through each thin leaf while camera and computer systems scan the surface area, grade the quality, and assign a unique tracking code to every bundle. In the sample room, architects and luxury car brand representatives can inspect the physical leaves in person, selecting the exact grain profile needed for their custom designs. To produce large format sheets, the edges of narrower veneer strips are clipped perfectly straight by a guillotine cutter. They are then fed into a splicer, which uses heat-activated glue to seamlessly join the edges together, creating a unified, large-scale grain surface. Beyond natural veneers, the mill also produces engineered veneers, dyed and regrained for color and pattern consistency, as well as cut-to-size spliced faces tailored to specific design specs. Additionally, the facility houses a massive inventory of solid lumber and live-edge slabs. Bundles of finished veneer are loaded onto trucks by forklifts, ready for export around the globe. The final culmination of this intricate process is seen in exquisite wood finishes adorning symphony halls, private jet interiors, luxury automotive dashboards, and world-class architectural landmarks. Next, join me as we visit Visa Prom, a prime example of the power of modern wood processing technology. This is far more than just a material production line. It is a refined process of resource transformation, where nature and precision engineering merge seamlessly into one. The process begins right in the timber plantation. Loggers use heavy-duty chainsaws to fell mature hardwood trees. As soon as a tree goes down, the branches and foliage are stripped clean, leaving only the primary trunk. After being collected at the forest landing, the timber is loaded onto trucks and hauled to the factory. At the processing plant, heavy-duty forklifts work like shuttles, continuously feeding raw material into the line. The timber is passed through an automated crosscut system. Here, a massive saw blade bucks the logs into shorter lengths with exact precision, tailored to fit the rotary veneer lathe. Wood scrap and trimmed ends are separated and routed to the energy recovery unit. Now comes the core processing stage for these solid logs. Hydraulic crane arms feed the log into position on the debarker. Here, dual spindles clamp both ends, spinning the log at high speeds. A planer knife presses tightly along the trunk, instantly stripping off the rough bark and uneven surface knots. Immediately after surface cleaning, the bare log moves to the high-speed rotary veneer lathe. This is a breathtaking display of precision engineering. As the spindle reaches operational speed, an ultra-sharp lathe knife, driven by a hydraulic feed system, advances toward the core at microscopic increments. The magic unfolds. From a solid piece of timber, thin ribbons of wood veneer begin to stream out like giant sheets of silk. The veneer thickness is maintained uniformly at a few millimeters with near zero tolerance, guaranteeing structural integrity for subsequent lamination. The continuous veneer ribbon, spanning tens of meters, travels at high speeds down the outfeed conveyor system. At the end of the line sits an automated clipper integrated with laser sensors. The scanner inspects the wood surface to detect natural defects, like cracks or large knots, instantly triggering the blade to cut the continuous sheet into standardized individual panels. Still saturated with natural moisture from the forest, these veneer sheets are neatly stacked by operators, ready to enter the thermal drying kilns. A modern processing industry is measured not just by productivity, but by self-sustainability. In this massive boiler, bark, wood scrap, and sawdust from previous stages are repurposed as fuel, transforming waste into an on-site renewable energy source. The high-pressure steam generated by combustion powers the next critical step: hot pressing and drying. Though thin and flexible, the newly peeled veneer strips still retain high moisture levels, leaving them wavy and prone to warping. To achieve the dimensional stability required for subsequent stages, they must undergo one of the mill's most crucial operations: hot press drying. With seamless coordination, operators carefully feed the wet veneer sheets into the openings of a multi-opening hot press, a massive steel giant radiating intense heat. The thermal energy is supplied by high-pressure steam, piped directly from the boiler system. Once the daylights are filled, the heavy steel platens slowly close to begin the pressing cycle. Hundreds of tons of hydraulic pressure force the heated platens against both faces of the veneer. The machine hums continuously, punctuated by loud huffs of white steam escaping into the air and enveloping that corner of the plant. Under the simultaneous force of high temperatures and hydraulic pressure, moisture trapped deep within the wood cells rapidly evaporates and escapes. Yet this process does more than just dry the wood. The combined heat and pressure erase the natural memory of warp and twist within the grain, resetting the entire surface profile. When the cycle ends and the press opens, the once waterlogged, rough and wavy sheets emerge bone dry, dense, and perfectly flat. Immediately after, the veneers are placed on metal racks to cool down naturally. This cooling phase allows the fiber structure to stabilize, locking in flatness before moving to the next stage. But how can these delicate sheets bear the load of an entire structure? The secret lies in the glue spreading and layup process. After being trimmed square, each sheet passes through a roller system to receive an even coat of specialized adhesive. Next, the layers are stacked according to a key principle. The wood grain of each layer runs perpendicular to the layer beneath it. This cross-graining minimizes shrinkage, enhances stability, and disperses weight in multiple directions. That is the core secret behind the extraordinary load-bearing strength of industrial plywood. Following the press shaping and inspection stages, the finished plywood packs are measured, bundled, and securely strapped before forklifts load them onto trucks. As the tarps are tied down and the trucks roll out, the journey at the mill comes to a close. From raw logs deep in the forest, through a series of modern processing operations, they have been transformed into sustainable building materials, ready to help shape new living spaces. And so, we have reached the end of a long journey, from standing trees deep in the forest, through harvesting, transport, sawing, peeling, drying, sorting, pressing, and finishing, to finally emerging in completely different forms, from sturdy structural lumber and resilient plywood panels to delicate veneers carrying nature's one-of-a-kind grain patterns. Looking at a piece of finished wood, it is hard to imagine the massive manufacturing chain behind it. Yet, what is most remarkable isn't just the sheer size or raw power of the machinery. It is the level of precision humanity has achieved in processing one of our oldest materials. A log, seemingly just a block of raw timber, can be analyzed, cut, and treated in countless ways to maximize every bit of its value. Suitable logs become building construction material. Trees with extraordinary grain patterns are sliced into veneers just fractions of a millimeter thick to adorn high-end luxury spaces. Other thin veneers are cross-laminated, glued, and pressed under immense force into plywood, with exceptional stability and load-bearing strength. Even the portions that seem valueless are rarely wasted. Bark, sawdust, wood chips, and trim ends are repurposed into raw materials or fuel to power the very operations downstream. A closed-loop cycle forms right inside the plant, where every last fraction of the tree is fully utilized. That is what makes this entire journey so compelling. From a resource shaped over decades in nature, wood is transformed through the synergy of mechanical force, technological precision, and human expertise into a wide range of products built for completely different purposes, whether framing a house, outfitting a luxury vehicle interior, or refining a world-class architectural landmark. So, the next time you see a piece of lumber, a sheet of plywood, or simply a beautiful wood grain surface, you might see it in a whole new light. Because what lies before you isn't just a finished product, but the culmination of a technological chain stretching all the way from the forest to the factory. It is a journey that starts in nature, passes through giant machines and human precision, and ultimately turns a single forest tree into the materials shaping the world we live in. Thank you so much for joining me on this journey. If you found this video interesting, don't forget to leave a like, subscribe to the channel, and share it. It gives me the motivation to bring you even more fascinating deep dives in upcoming videos. Thank you, and I'll see you in the next one.